Good morning, children.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, children. Good morning. Okay, so what are the three important trigonometric ratios, children? The three important trigonometric ratios. What are the three important trigonometric ratios, also called T ratios?
Sine, cos, and tan.
Very good. Sine, cos, and tan. Three important T ratios. T ratios meaning trigonometric ratios. T ratios, trigonometric ratios. So the three important trigonometric ratios or T ratios are sine of an angle or sine theta, cos theta, cos of an angle. So sine of angle theta, sine of angle theta is sine theta. Cos of angle theta is cos theta. And tan of angle theta is tan theta. So if the acute angle, if the reference angle, it's also called the reference angle. The reference angle, if the reference angle is A, so sine of angle A is written as sine A. You don't have to write the angle symbol. You don't have to write like this. You don't have to mention the angle symbol here, because whatever comes after sine is always an angle. Sine is always followed by an angle. In fact, all the T ratios are followed by an angle. So you don't have to mention the symbol here, angle symbol here. So sine of angle A is written as sine A. Cosine of angle B is written as cos B. Tangent of angle C is written as tan C. So sine, cos, and tan, these are the three important trigonometric ratios. Now the reciprocal ratios. They're reciprocal ratios. The reciprocal ratios. So the reciprocal of sine A is, what is the reciprocal of sine A?
Cosecant theta.
Cosecant A. Cosecant A. Tell me if this is right. Is this true or false?
True, ma'am.
Yes, ma'am.
Is this true or false?
False, ma'am.
False. Why, Sashank?
Ma'am, because it is reciprocal of sine, not equal to sine.
Correct. So this is incorrect. You should not write sine A is equal to cosecant A. This is wrong. You can write in words like this. The reciprocal, in words you can write like this. The reciprocal of sine A is cosecant A. If you want to write it symbolically, then you must write sine A is equal to 1 by cosecant A, or cosecant A is equal to 1 by sine A. They're not equal. Sine A and cosecant A are not equal. Sine A is not equal to cosecant A. Sine A and cosecant A are reciprocals of one another. So sine A is equal to cosecant A is wrong. In words, you can write like this. The reciprocal of sine A is cosecant A, or the reciprocal of cosecant A is sine A. Symbolically, it's like this. Sine A is equal to 1 by cosecant A. Cosecant A is equal to 1 by sine A. Okay. What about the reciprocal of cos B? What is the reciprocal of cos B?
Secant B, ma'am.
Yeah, but how do I write it? I need to complete this. Cos B is equal to
1 by sec A.
1 by, yeah, I told you can call it sec or secant. And I told you that I'm used to saying secant. I'm not used to saying sec. But here in most schools, it's pronounced sec. Maybe that's the right way, but I'm not wrong either. Okay. So secant or sec. Okay. So both are the same. So secant is the full thing. I'm reading the full thing, secant. So you can short the pronunciation like sec, which you will not find me using. Okay. So I say cos B is equal to 1 by secant B. So cos B is equal to secant B is wrong. This is wrong. It's incorrect. Is this right, children? Secant B is equal to 1 by cos B. Is this correct? True or false? Secant B is equal to 1 by cos B.
True, ma'am.
True. This is true. Yeah, now tell me, is this true? Secant A is equal to 1. I've shared my screen, children. Is it visible?
Yes, ma'am. Yes.
Yeah. Okay. So secant A is equal to 1 by tan B. Is this correct? Oh, sorry.
False.
No. One second. Secant B is equal to 1 by cos A. Is this correct?
No.
False, ma'am.
Because the reference angle also should be the same. It's not that, okay, there is secant here, there is cos here. Let me write it clearly. SCC, secant B is equal to 1 by cos A. So we know that secant and cos are reciprocal ratios. But it's important that the reference angle is also the same. The reference angle must also be the same. Secant and cos are reciprocal. So secant is equal to 1 by cos. Okay, that looks correct. But what about the reference angle? B, here it is A. So secant B is equal to 1 by cos B. So secant B is not 1 by cos A. This can be true only if angle B is equal to angle A. If angle B and angle A, the value like both are 45 degrees or, like whatever, if they have the same measure, then yes. But you cannot assume that. Okay, so this is wrong. If you're asked this is false. When can this be true? Only if angle B is equal to angle A. If both of them have the same measure, yes, then it's right. But if you have to answer this, if this is true or false, it is false. All right. So similarly, tan A or tangent of angle A, tangent of angle A, or simply tan A. The reciprocal of tan A is
1 by cot A.
1 by
Cot A.
1 by cot A. 1 by cot A. Also, cot A is equal to 1 by tan A. 1 by tan A. Okay. So all this we saw in the first class, the introduction class to trigonometry. Okay, now coming to the 3 trigonometric identities. The 3 important trigonometric identities. Okay, the trigonometric identities. Tell me in terms of angle C. Tell me in terms of angle C. Use angle C and tell me.
Sin C plus cos C is equal to 1.
Okay, thank you, Sashank. Yeah, friends, please comment if this is true or false.
Ma'am, sin square C.
Very good. Sin square C.
Cos square C.
Cos square C is equal to 1. Yeah. So sin square C plus cos square C is 1. This identity cannot be manipulated like, you cannot say sine square c plus cos square c is 1. That means sine cubed c plus cos cubed c is also 1. No, it cannot be manipulated like this. It cannot be manipulated by like this. Sine square c plus cos square c is 1. That's all. If the power is different, you can like use the same, the pattern and construct your own identity. Sine square c plus cos square c is equal to 1, or sine square a plus cos square a is equal to 1. So sine square theta plus cos square theta is equal to 1. The reference angle is theta. Okay, so this is the first one. Then
tan square theta minus cosecant square minus secant square theta is equal to 1.
no.
Cosecant
Tan square
square.
theta minus tan square theta minus secant square theta is minus 1.
Ma'am, cosecant square c plus.
No. You work on what? No. You work on what Sashank said. Don't tell me the next one. Sashank started something.
Secant square theta minus tan square theta is 1.
Yeah, secant square theta minus tan square theta is 1. See here in the first one, sine square theta plus cos square theta is 1. Also, cos square theta plus sine square theta is 1. You understand why? Because the connecting sign is plus, you can also say it the other way. Cos square theta plus sine square theta is also 1. Like you're saying a square plus b square is 1. This also means b square plus a square is 1. So you're not changing the identity. The meaning of the identity is the same. But when it is secant square theta minus tan square theta is equal to 1, you cannot say that tan square theta minus secant square theta is also 1. It will be minus 1. It will be minus 1. Tan square theta minus secant square theta is equal to minus 1. If you want to know how, change the signs on both the sides. Change the signs on both the sides. So it will become minus secant square theta plus tan square theta is equal to minus 1. Change the signs. There are 3 terms. 1, 2, 3. Change the signs for every term in the identity. Plus secant square theta becomes minus secant square theta. Minus tan square theta becomes plus tan square theta. Plus 1 becomes minus 1. Changing the signs throughout. Now, what is this? Plus tan square theta. So let's write this one first. Let's write this first. And then we'll write this minus secant square theta. So it is minus 1. Tan square theta minus secant square theta is minus 1. Okay, what's the next one, children?
Cosec square theta minus cot square theta is equals 1.
Okay, so cosecant square theta minus cot square theta is equal to 1. So I remember everything in terms of 1. And that's how I teach. Everything in terms of 1. So there might be a slight difference in the way your school teacher says. She might say 1 plus tan square theta is secant square theta. See, she might say 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Fine. This one's cosecant square theta. It's the same. 1 plus, see, the first one is like this always. Sine square theta plus cos square theta is 1. The other 2 identities, you can also find your teacher saying 1 plus tan square theta is secant square theta. 1 plus cot square theta is cosecant square theta. You know, when you transpose, it's the same. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. So I remember everything in terms of 1. So cosecant square theta minus cot square theta is 1. Now, changing the signs on both the sides, you'll get minus cosecant square theta plus cot square theta is equal to minus 1. So we'll write the positive term first. So we have cot square theta, and then we'll write this one. So minus cosecant square theta is equal to minus 1. So cosecant square theta minus cot square theta is 1. But cot square theta minus cosecant square theta is minus 1. So these are the 3 important trigonometric identities. And you know that these identities can be interpreted in many ways. So we saw all that in the last class. And children, I think last night I shared the notes also. to the introduction we had in the first session of trigonometry. I shared all the notes. So please write down all that in your tuition notebook. All right. How many of you finished writing? How many of you are done writing?
I completed, ma'am, Rakshita.
Rakshita. Okay, nice. Very good. Yeah, others, I'm sure you would have been occupied with some other work, with school or whatever. So please complete it, children. Yes,
Or,
somebody, somebody else wanted to. Yeah, okay. So today, make sure you complete it today, children. All right. Yeah. So that's about trigonometric identities. All right. So now you would have seen in standard 9 that using some basic algebraic identities, we were able to prove some other identities, but we didn't have many questions like that, but we have done a few, in the chapter, in the second chapter, polynomials, using some basic, using some basic algebraic identities, we proved some other algebraic identity. In the same way now, using these three basic trigonometric identities, we are going to prove many other trigonometric identities. I repeat, in class 9, we learned a few algebraic identities. Using these identities, or these identities were used to prove some other, like larger or some bigger bigger algebraic identities. In the same way here, these are the three basic trigonometric identities. We're going to use these identities or their interpretations, whatever. These identities can be interpreted in different ways. Okay, so we're going to use these three trigonometric identities to prove many other trigonometric identities. So that's what we're going to see in today's session. Yeah. So if you have not written the introduction part of this chapter, please leave some pages. Please leave some pages and then start writing this. So I'll give you some time to just judge how many pages you'll have to leave. Please leave that and then start writing this, children. Secant A into 1 minus sin A into secant A plus tan A is equal to 1. Done writing, children?
Yes, ma'am.
Okay. All right. Okay. So to begin with, we take up the LHS. We take up the LHS. LHS is secant A into 1 minus sin A into secant A plus tan A. This is the LHS. Take up the LHS. So we know the basic fundamental as to how to prove something. You need to take up, see, it's an equation. So you either take up the left hand side or the right hand side. You work that and arrive at the other side. So here we take up the left hand side. We work, we do something. And finally we get 1 as the result. So you work with the LHS and you get 1. That means you've got the RHS. That means LHS is equal to RHS and hence the identity is proved. Yes or no, children? Okay. So take up the LHS. Now, first rule, change other ratios to sine and cos, sine or cos. That's the first rule. Okay, so, like as in when we do different we proved different identities, we'll be coming across certain rules. Please make a note of the rules. Okay, so here the rule in this identity, the rule meaning to prove this identity, we're going to use a rule always. Okay, the rule is change other ratios to sine or cos. See, I told you the other day, children, sine alone has no meaning. This is just for us to understand. Sine has no meaning. Cos has no meaning. Sine of what angle? Cos of what angle? But I will be using sine cos. But remember that it has no meaning. Now, one more thing is, children, when we say sine A, okay, now in algebra, when we say xy, it is x into y, right? When we say x, y, z in algebra, it is x into y into z, correct?
Yes, ma'am. Yes, ma'am.
That's not true with sine A. Sine A is not equal to sine into A. Sine A is not sine into A. Because as we know that sine does not exist. There's nothing like sine. There's nothing like this. This is meaningful only if it is attached to an angle. This is meaningful only when it is with respect to some angle. So sine A, yeah, sine A. So that sine A is one complete thing. Sine A is not sine into A, like xy is x into y. Sine A is not sine into A. This is one whole it is. You cannot see it as sine and A. It's one whole thing. Sine A, cos A, tan A is one full thing. Okay, so remember that sine A is not the product of sine and A. Sine A, or in fact, cos A or cos B. Cos B is not the product of cos and B. Okay, so what is the rule? Change other ratios to sine or cos. So what is how do you write secant A in terms of sine or cos, children? What is the reciprocal ratio? What's the reciprocal of secant A?
1 by sine.
1 by cos A. So write secant A as 1 by cos A. So see, we have changed other ratios to sine or cos. So secant A is written in terms of cos. Now here, this is 1 minus sine A. Write that as it is. It's only sine, no? So you don't have to change that. Here again, secant A is 1 by cos A. And what is tan A, children?
Sine by cos.
Very good. Yeah, tan A, sine A by cos A. We saw this in the first session. We didn't recall this today. Okay, but I've told you. Tan A is sine A by cos A. So now this is the first step. You must write other ratios using sine or cos. That's the first step. So you can see here, secant A is written as 1 by cos A, 1 minus sine A as it is because there's only sine in it. And you don't have to change the numbers. Constants can remain as it is. The other ratios you must change to sine or cos. Secant A is 1 by cos A, tan A is sin A by cos A. All right, this is the first step. Next step. 1 by cos A. Now, see, you know what? It's completely algebra. Trigonometry is just algebraic knowledge. Trigonometry is just algebra. You just have to use the trigonometric identities here and there. That's all it is. It's so much dependent on your algebraic knowledge and your algebraic skills. So that's all. Beyond this, there's nothing about trigonometry. What would you do here? What is the meaning of this one? This is nothing but, see here, 1 minute. Let me write it like this. Don't go ahead of me, children. Please wait. Now you can see it's a product everywhere, right? It's a product. It's 1 by cos A into 1 minus sin A into something. Correct? So you can just, after taking the LCM here in this bracket, you can just multiply the numerators and multiply the denominators because it's a product everywhere. So see here, first I'll multiply these two. So I'll write this 1 minus sin A by cos A. I hope you understand that. It's like if you have 1 by y into x. If you have 1 by y into x, you'll write it as x by y. If you have 1 by y into x, you'll write it as x by y. So 1 minus sin A by cos A. Here, we have to take the LCM. The common denominator is cos A. So 1 plus sin A. Okay, common denominator. Cos A is a common denominator. So 1 plus sin A. Now see, it's a product. So multiply the numerators, multiply the denominators. It's a product you can see here. Multiply the numerators. So it will be 1 minus sin A into 1 plus sin A divided by cos A into cos A. Cos A into cos A. So what is this is like A minus B into A plus B. 1 minus sin A into 1 plus sin A is like A minus B into A plus B. And what is A minus B into A plus B, children?
A square minus B square.
A square minus B square. So what should I write in the numerator here?
1 square minus sin A whole square.
Sin A, the 1 square minus sin A, the whole square, divided by cos A into cos A is
the whole square.
cos A the whole square. Cos A the whole square. Okay. Next step. 1 square is 1 minus sin A the whole square. How do we write sin A? The whole square? Sin square A, correct. Sin square A. Sin square A divided by cos A the whole square is cos square A. Cos square A. Very good. Now we know that sin square theta or sin square A plus cos square A is equal to 1. So on transposing, this is from the interpretation. So cos square A is equal to 1 minus sin square A. Yes or no? Sin square A plus cos square A is 1. So cos square A is 1 minus sin square A on transposing. So what is 1 minus sin square A? Cos square A by cos square A, which is 1, which is the RHS. So LHS is equal to RHS, hence verified. Or you can also do like this. Or what you can do is 1 minus sin square A you can write as it is by, you can write cos square A. What is cos square A? 1 minus sin square A. What is cos square A? 1 minus sin square A. You can change anything. It's not that you should change only the numerator. But we always, you want to make bigger things smaller, right? So 1 minus sin square A can be written as cos square A. But this is also not wrong. You can write cos square A as 1 minus sin square A. So this gets cancelled and it's 1. Anyways, I hope you understand what I'm saying, children. Am I clear?
Yes.
Yes, ma'am.
Don't change both. Then you cannot cancel out them. Don't change both. You must change any one. Any one. So either here what I've done is 1 minus sin square A is replaced with cos square A. So cos square A by cos square A, 1, which is the RHS. Or write the numerator as it is. Write the numerator as it is by cos square A is 1 minus sin square A. So they get cancelled and it's equal to 1. Is equal to the RHS. Both are fine. So LHS is equal to RHS, hence verified. Or hence proved, however you want to finish it. Write down, children. Please write down. Now you cannot take long time to write because you have understood. Just write down from the screen. Let me know, children. Once you're done, I'll take you to the next slide. Done, children?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
Completed, ma'am.
Yes, ma'am.
All right. Yeah. So this is the rule, this is the first rule you have learned, children, and this is the most important rule. This is the most important rule. Changing other ratios to sine or cos. Can we go to the next one, children?
Yes, ma'am.
Okay. The heading is the same. The heading is prove the following trigonometric identities. So today's class is all about that. So that's the main heading. cot A minus cos A by cot A plus cos A is equal to cosecant A minus 1 by cosecant A plus 1. Okay. So take up the LHS. So now you know the rule. So tell me what should be the next step?
To change the ratios of cot.
Correct. So how do you write cot? Cot is equal. See, cot A is also 1 by tan A. Cot A is also 1 by tan A. No, this is correct, but this is preferred. Cot A is equal to what?
Cos A by
Cos A by sin A.
Cos A by sin A. This is preferred. This is preferred. So cot A is equal to cos A by sin A minus cos A. Correct? That numerator. The numerator. Okay. Divided by. Tell me what? What's cot A?
Cos A by
Cos
sin
A by
A.
sin.
Cos A by sin A. Plus cos A. Plus cos A. Now tell me, children, what should be the next step? Actually, it's not what you think. Let me see, but if you can find it out. No. I said no, it's not what you think. All of you are thinking about it. It's not that. It's something else. Guess what?
Sin A will get cancelled.
Sine and sine, where, darling? Sine and sine. This one, huh? The sine and the sine.
Yes, ma'am.
No, this is one expression here. When we have A by B minus C by A by B plus C, you know what? This is a package. A by B minus C is one thing. They cannot be cancelled with anything else. Because A by B minus C, the connecting sign, if the connecting sign is plus or minus, this is like one unit now. When it is A by B into C, there is no unit at all here. Here A is free, B is free, C is free. Everyone is free. You can cancel if you want. But when the connecting sign is plus or a minus, this becomes a unit. You cannot simplify this at all. See, even if there is 4 here and 2 here, you cannot cancel 2 ones or 2 twos. You cannot do that. Because we'll have to make it 1, meaning A by B plus C. Suppose you should take out B, meaning you should take B as a common denominator and A plus BC. This is the next step. You must add or subtract them. So, yeah, you cannot cancel.
we have to change the RHS.
Sorry?
We have to change the RHS.
No.
Transpose.
No. Oh, very good, very good. Transpose. See, we are working with an expression. We have taken up one side of the equation. So this is an expression. There is no place to transpose at all. We are not working with an equation. See, when we are working with an equation like this, then you can transpose. We are working only with this A plus B. It's an expression. So there is no question of transposing.
Yes, ma'am.
Yeah.
Ma'am, a reciprocal.
No. It's a very simple idea. You'll all be like, oh my God.
Should we change the
No.
denominator or the numerator into variable and...
No. It's simpler than that. Okay. Now I think you can get it. If it is A by B minus A, what do you think you will do?
LCM.
Before that,
A by 1, ma'am.
I think you're close, Danya. A by 1, no. Okay, A by 1. Okay, A by 1. Okay. Okay, fine. So simple things we forget easily. Actually, you know it. All of you know it. So again, this is a golden rule. I call it the golden rule. Whenever there is something common, please take out the common factor. Whenever this holds good, even in algebra. See here. Okay, 1 minute. How do you think you factorize this? For example, factorize this, children. Factorize this one. Use an identity and factorize this.
Ma'am, a into a power 3 minus 27.
So what did you do? A into a power 3 minus?
Minus 27.
So you took out the common factor. If you don't take out a common, you cannot factorize this. You have to take out the common factor a. Only then this looks like x cubed minus y cubed. That is a into a cubed minus 3 cubed. So this is like x cubed minus y cubed, where x is a and y is 3. So a into x cubed minus y cubed. Yeah, complete the identity. X cubed minus y cubed is equal to. Think. I don't want instant answers. Think. We've seen this in this year also, meaning in 10th standard in the second chapter, polynomials.
X minus y the whole cube.
No. You try, Prajit. Okay, so what Prajit can do is, see, all of us will get ideas like this, but what you need to do is, you need to tell yourselves that you're wrong by taking some values. Now you're saying x cubed minus y cubed is equal to x minus y the whole cube. Nothing wrong in thinking like this. But you need to, like, you can help yourself. Now let's say, let x be equal to, we'll take a small number like 1. It may be true for some values, but it is not always true. Something is true only if it is always true. Even if there is one exception, it is false. Even if there is one exception, it is false. So now let's say, let's take, like x1 and y2. Okay. So what is x cubed minus y cubed? So it'll be 1 cubed minus 2 cubed, 1 minus 8, which is minus 7. So this is the value of x cubed minus y cubed. Now let's work x minus y the whole cube. So it'll be 1 minus 2 the whole cube. 1 minus 2 is minus 1. Minus 1 the whole cube is minus 1. Where are they equal? Where are they equal? So clearly x cubed minus y cubed is not equal to x minus y the whole cube. X cubed minus y cubed is not equal to x minus y the whole cube. Every time we get, if every time our mind believes that this is correct, you can just tell yourself, just take some values, simple values, and work both the sides. If you're getting the same answer, then it is true. If you're not getting the same answer, it is false.
X minus
So we need
y
to unlearn this, children. Most of us need to unlearn this one. Unlearn this and learn it correctly.
x minus y into x square minus y square minus 3xy.
Ma'am,
Sorry,
we should
come
take
again? No, what is it, Sashank? X cube is equal to?
X minus y into x square minus y square minus 2.
No, you're not sure, but it's not right also. The signs are incorrect. Okay. All right. So children, x cubed minus y cubed is equal to x minus y into x square plus xy plus y square. X cubed minus y cubed is equal to x minus y into x square plus xy plus y square. X cubed plus y cubed is equal to x plus y into x square minus xy plus y square. See, this is in this position and this position. If it is x cubed minus y cubed, it starts with x minus y. Then this is plus. If it is x cubed plus y cubed, this one will be plus. This will be minus. This position I'm saying, this one. The terms are the same in both. The terms are the same. The factors, they look identical except for the signs. If it is x cubed minus y cubed, you start with x minus y. If it is x cubed plus y cubed, you start with x plus y. Then if you use a minus here, then this one will be, this is like the middle term. This is like the middle term, So if it's minus, it will be plus here. If it's plus here, it will be minus here. The other terms are always positive. X square, plus x square, plus y square, plus y square. Now tell me, class, what is x cube plus y cubed?
X plus y into x square plus y, xy plus
X square?
plus xy.
No.
Minus xy plus y square.
Yeah, then what is x cube minus y cubed?
X minus
X
y
minus y into x square plus y square.
X square plus?
xy plus
y square.
Very good. Very important, children. Even in 11th standard, 11th, 12th, algebra plays a very crucial part in mathematics. Everywhere, it might be a different branch of mathematics. There also you will have algebra. See, like in statistics also. Statistics is entirely a different branch of mathematics. But there also, while working, like when you had to find the missing frequencies, whether it sometimes mean is given, median is given, mode is given, you'll have to find the missing frequencies of x and y or f1 and f2. There also you had algebra. You get, like some equations and you'll have to solve by the elimination method, whatever. Everywhere, algebra is everywhere. Be it whatever branch of mathematics. So you want to be good at maths, you have to be good at algebra. So when we say good at algebra, it just needs practice and that initiative to remember. That's all. No big deal it is. It's just practice. That commitment, interest, first interest. Or maybe before that, responsibility. Okay. Responsibility. So only when you assume some responsibility as a student, when you assume some responsibility, then you get that interest, then you take efforts, and efforts will pay off. Efforts will pay off. Nobody can say that I did this, but I was not rewarded. Your reward may not happen soon, but it will happen someday. So please remember this, children. All right, now coming back. So taking out the common factor is the next step. Now what's common, children? So how do you handle this? Coming back here, AB by minus A, what do you do here?
A 1 by B minus 1.
Yeah, minus 1, correct. A into 1 by B minus 1. Same thing here. Cos A is common, take it out. By, into 1 minus sin A minus 1 divided by, what's that? Yeah, cos A again common, bracket 1 by sin A plus 1. Now next what, children?
cancel the cos now.
Yeah, cancel cos A in both the numerator and the denominator. Cancel cos A. Now, the other thing is, you need to constantly look at the RHS, the other side. If you're getting the result, am I close to the RHS? Am I close to the RHS? Because it's like a race, you start from one end, you want to reach the other end faster. So you started with the LHS, now you are working for what? You're working for some cause. You want to reach the RHS quickly. So keep looking at the RHS. Am I close to it in any way? And I feel we are close to it because here this minus 1 we have and we have plus 1 also. In the RHS here, see minus 1 and plus 1. Oh, looks very close. Just that this is cosecant A, but I have 1 by sin A. So what's the next step, children? Again, it's not what you think. Now, what are most of you thinking? LCM?
Ma'am, 1 by sin A is equal to cosecant A, ma'am. So that we have to write cosecant A plus minus 1 by cosecant A plus 1, which is equal to RHS, hence verified.
Very good. That's what it is. So you should not again take the common denominator. You must not say by sin A and 1 minus sin A. Don't do that. Now the next question is, if I do, will I not get the answer? You will get it, but you will take a few more steps. You will take a few more steps. Take a shortcut. You have to reach the destination. Will you take a long route or a shortcut? Take the shortcut. So now when you compare where you are to the right hand side, we are here. When you compare this with the RHS, you can see -1, +1 in the numerator and denominator, -1, +1. Except that we have 1 by sin A here, while we have cosecant A here. But we know that 1 by sin A is equal to cosecant A. So in the next step, 1 by sin A is cosecant A -1 by, again 1 by sin A is cosecant A +1 is equal to RHS. So you see that the LHS is equal to RHS, hence proved. So the two rules you learned here are, one, what are the rules you learned here, children?
Take the
Common factor, correct? Taking out the
Factors.
common factor. Taking out the common factor. Or the common term or the common ratio. See, taking out the common expression. Common expression or common term. See, okay, common term, common expression, whatever. Then the other thing we learned is have a track of the RHS always. As you're working, keep having a track of the RHS. Keep looking at the RHS. Am I close to it? Am I close to it? Only then you will realize. Otherwise, we'll keep taking the LCM and we'll move at, we'll take a longer route. So compare, keep checking the RHS. Keep checking your, position with the RHS. Only then you will realize that you're close. All right, children, please complete this one. Yes.
Can we also take a common factor as cos A by sin A into 1 minus cos A by 1 plus cos A, like that?
Common factors, cos A, you want to take out cos A by sin A common, is it?
Yes, ma'am. Even though, can we do it?
Okay, no, that's not visibly common. You are taking it out. How is, see?
No, ma'am, for both the denominator and the numerator, so that.
Okay, in both the numerator and denominator, see, common factor is taken out only in one expression. That expression is either in the numerator or in the denominator. We don't take out common between the numerator and the denominator at a time. See, when you take out the common factor, you're looking at an expression. That expression may be in the numerator or in the denominator. You cannot take out something common which is in the numerator and the denominator. You're not looking at, you look only at the numerator or only at the denominator while taking out the common thing. So there's nothing like looking at these two and taking out. This is what you're saying, right?
Yes.
No, see, it's not that you will not get the answer. You will get it. Let's work it like that. Complete this, we'll work it like that. It is possible. Shashank, the answer to your question is it is possible. It's not impossible. It is possible. But when we take out common, we look at only the numerator or only the denominator, not both, but I'll also work it the way you want it. But remember, every time, all the ideas of us may not work. This one, I'll work it for you.
Okay.
Yeah. Done writing, children? Done, children?
Yes, ma'am.
Okay. Some of you missed the class on Saturday. Did you all watch the recordings? Sorry, watch the recording.
Yes, ma'am. I did.
Okay. Okay. Okay, so alternate method, also called the Shashank's method. Okay, alternate method. Cot A minus cos A. Okay, so cot A minus cos A divided by cot A plus cos A. So this is cos A by sin A minus cos A divided by cos A by sin A plus cos A. Now if you take out cos A by sin A common, the whole thing common, then you'll get 1 minus what? 1 by sin A, correct? Sorry, so not 1 by sin A into sin, 1 minus sin A, correct?
Cos A, ma'am.
This is what you meant, right, Shashank? Shashank?
It's cos A, right? Okay, okay, ma'am. Now I understand.
Cos A by sin A into 1 is cos A by sin A. Then when you multiply these two, when you multiply cos A by sin A into sin A, sin A and sin A will get cancelled, so you'll get cos A. This you have cos A only, no? Here. Yeah. Then again cos A by sin A common 1 plus cos A by sin A into what? Into what will give you cos A? So into sin A. So here it is sin A. Because this into this, when you multiply these two, you will get cos A. You multiply these two, you will get cos A. Okay. Now, as Shashank says, this will get cancelled. Correct? So now we have 1 plus 1 minus sin A by 1 plus sin A. What is it here? Cosecant A minus 1 by cosecant A plus 1. You need to get cosecant, but where are we? Sine. The RHS is cosecant, but where are we? Sine. So what should you do? Common denominator, sorry, change sine to cosecant. Now your question may be, we have to write other ratios in sine. Why you're changing sine to cosecant? That's the requirement here. We have to keep tracking the RHS. You see that the RHS is cosecant A minus 1 by cosecant A plus 1, but we have sine here. So we have to change sine to cosecant because that is what is in the RHS. So change. So what do you get? 1 minus 1 by cosecant A divided by 1 plus 1 by cosecant A. So common denominator, cosecant A is a common denominator, cosecant A minus 1 by cosecant A plus 1 by cosecant A. So cosecant A and cosecant A gets cancelled. So we have cosecant A minus 1 by cosecant A plus 1, which is the RHS. So you can see that a few more steps we need. So that's what I told you. Told the class, in fact. You can do, but sometimes it will take a few more steps. That's all, but you'll get it. But sometimes it'll be really lengthy. You will be like, why the hell did I do it like this? I should have followed the, the standard version. Yeah. Yeah, please make a note of this also, children. Yeah, please make a note of this. Done writing, children? Florentina, finished writing? Raghavi, finished? Danya, finished writing?
Yes, ma'am.
Okay.
Ma'am,
Yes?
ma'am, you told that the both numerator and denominator are both different expressions, ma'am. Then how did you cancel cosecant A and cosecant A, ma'am?
Okay, I'll show you the steps for that. No, nothing is new. Okay, so these are things which we already know, but just that when it comes with the ratios, cosecant and all that, we are finding it different. I'll tell you. Now, this one is cosecant A minus 1 by cosecant A divided by, correct? Okay, let me do it for all of you. 1 minute. Let me change the steps so that all of us understand why it's like that. Yeah. So this is nothing but, which is the numerator? This is the numerator, correct? This is the numerator. This is the denominator, correct?
Yes, ma'am.
Okay. So next step is cosecant A minus 1 by cosecant A divided by, right? Divided by cosecant A plus 1 by cosecant A. Is this correct?
Yes, ma'am.
Okay. This one. Okay. So now after this is equal to cosecant A minus 1 by cosecant A into cosecant A by cosecant A minus 1, correct? Plus 1, because division becomes multiplication and reciprocal, correct?
Yes, ma'am.
Now you can cancel, right? Cosecant A and cosecant A can be cancelled, yes or no?
Yes, ma'am.
Okay. So cosecant A minus 1 by, which is the RHS. Yeah, you can include the step children for clarity. Please include that step for clarity. You can just put a line and write beside it. I want all of you to make a note of that. Done writing, children? Sashank? Am I clear?
Yes, ma'am.
Okay. How many of you have learned trigonometry in school? Raise your hand.
Ma'am, we have not completed, but we have started it.
Sashank? Huh?
Yes, ma'am.
Okay. Okay. Now, class, use the emoji. Raise your hand, all of you. Sashank, Prajit, Raja, Madhumita. Raghavi, I called out earlier, but there was no response. Shri Krishmi, Rakshita, Danya, Arjun, Sri Ranjanan, Florentina also. I called out to you, Florentina, there was no response. Mic is not working. All right, Raghavi. All right, I got it. Florentina, what is your reason? I called out, you didn't answer.
I was having network issues now and then the audio is not clear.
Florentina, does it happen like this that you sometimes you have to leave the meeting and rejoin because of network issues?
Yes, ma'am.
That's what happens, like when I open the, like the meeting window and look for the participants, I don't see you sometimes. That's why sometimes I ask you on WhatsApp, did you attend the last class? Because I don't open the Teams page, like frequently, right? Because I'm in the PowerPoint there. I'm writing there. I don't know, like when I start off, I know how many of you are there in the meeting, and then I don't know who leaves and rejoins because of network issues. But every time I see, I sometimes I don't find you here in the attendees list. That's why I text you on WhatsApp if you attended the class, and then you tell me that yes, I did attend. But this is the reason why, I just question you on WhatsApp. Okay, so does it happen frequently? And if it happens, how do you continue understanding the class? It doesn't affect you? Does it affect you?
I'm a little, ma'am. Not much.
Yeah.
After that, if it happens a lot, I watch the recording.
Oh. Okay, fine. All right, yeah. All right, children. So, are we good with this one? Can we go to the next one, children?
Yes, ma'am.
Yeah.
Ma'am, in this case, should we write the RHS in terms of sine theta and cos theta?
No, we are going to get started with the left hand side, right?
Yes, ma'am, but it's already in the form of sine and cos theta.
Yeah, correct. So that's why there's a different approach now. You're right. We are not going to take up the RHS. We'll always take up the complicated side, like the side which looks like can be simplified, you know. So, yeah.
Okay, ma'am.
Like the side which has more number of terms, you can see as you work, you know, you can make out from by just looking at the identity. So there should be something to work. Supposing one side has only one, you cannot take up that side and work. So we normally take up that side where, you know, there is some changes can be made and eventually we arrive at the RHS. But there are cases where, you know, we have to take up the left hand side, work it. Say you get an answer like 5. Then you should take the RHS also and work it. You should get the same 5. Then LHS is equal to RHS, hence verified. There are cases like this also, where you have to work the LHS, work the RHS separately. Work the LHS, get some result. Work the RHS and get the same result. Like this also, we prove a few identities. Most of them can be proved by taking the LHS. You take the LHS, you work and get the RHS. Most of it works like that. Sometimes you have to work both. Work the LHS, have the answer, have the result. Then work the RHS, have the result. Now compare the results, they'll be the same. So since the result you got in the LHS is the same as the result you got in the RHS, you conclude that LHS is equal to the RHS, hence verified. Yeah. So here, children, it's already, as Madhumita mentioned, in the left-hand side, the ratios are already sine and cos. Then what to do? Now, this is a standard identity, meaning it's a standard way of working. So you need to remember this. If you do it like this, you do it in fewer steps. If you're experimenting, you will get it. But how long it will take, I don't know. Okay. So now now this is a rule. Like, when do we use this rule? Now, when the LHS is made up of sine, cos, and 1, when the LHS meaning any one side, LHS or RHS, but here it is the LHS. The LHS is made of sine theta, cos theta, and 1. Forget the signs. The signs can be plus, minus, whatever be the signs. The left-hand side, the expression in the left-hand side is made up of sine theta, cos theta, and 1. There's nothing apart from this. If it is like this, then the next step is to divide both the numerator and the denominator. Divide the numerator and the denominator by sine theta or cos theta. Divide the numerator and denominator by sine theta or cos theta. If the left-hand side is made up of sine theta, cos theta, and 1, then what next? We have to divide both the numerator and denominator either by sine theta or by cos theta. Now we'll have to choose. Only one of it is correct. Only one of it is correct. Like, choose the correct answer. It's not that you can do this or that. You should, for this situation, only one will work. So now we know the next step. I have to divide the numerator and the denominator by sine theta or cos theta. Now the next step is to decide whether it is by sine or cos. Is it sine theta? Should I divide by sine theta or should I divide by cos theta?
By cos theta.
So for that you should take help from the RHS. For this you should take help from the RHS. You must take help from the RHS. Now, how will the RHS help you? One way is you can work the RHS first. Or now I am not working. I have not worked the RHS first. So you just do this in the rough column. Okay. So do this in the rough column. Take up the RHS. And what is it? 1 by, what is secant theta? 1 by cos theta, correct? Minus, what is tan theta? Sin theta by cos theta. Is this correct?
Yes,
Yes,
ma'am.
ma'am.
Children, just a minute. This 1 second, children. Yes, where we stop. So we should take help from the RHS. Now look at the RHS. Yeah. The RHS is 1 by secant theta minus tan theta. Now, as I was telling you that if you want, when you see an identity like this, if you want, you can take up the RHS first and work that, and then work the LHS. You may do that or you may not do that. I'll work it both the ways for you. I'll do it both the ways for you. Now, what I have, the first method I'm doing here is I'm taking up only the LHS. I'm going to work this and get the RHS. That's what I'm going to do. So one method is you can work the RHS, which I'm going to do as the alternate method. Otherwise, you can just take help from the RHS. You can just take help from the RHS without working the RHS like this. You can just take help from the RHS. What are the ratios RHS is made up of? What are the ratios the RHS is made up of? Tell me. What are the ratios RHS is made up of?
Secant and tan.
Secant and tan. Now, just divide sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta. That is, you're dividing the numerator by cos theta. Now we're going to divide the denominator also by cos theta. Dividing meaning you should divide every term. Every term you must divide by cos theta. This is dividing. What I've done here is I've divided the numerator and the denominator by cos theta. Now dividing by sin theta means sin theta by sin theta minus cos theta by sin theta plus 1 by sin theta divided by sin theta by sin theta. You should divide both the numerator and denominator by sin theta. You can do one of this. One of this. Now, which one, in which one, where are you getting? Now, okay, simplify this, what will you get? You'll get tan theta here, right? Tan theta minus 1 plus secant theta, correct?
Yes, ma'am.
Yes,
What
ma'am.
do you get here? 1 minus, what do you get here? 1 minus?
Tan theta, no, cot theta minus secant theta, cosecant theta.
Plus cosecant theta. So when you divide, what we notice is when we divide the numerator and denominator by sin theta, it converts to the ratios cot and cosecant. Forget the signs and all that. We are not worried about the signs. We are only worried about the ratios. When you divide the numerator and denominator by sin theta, it converts to cosecant theta and cot theta. But when you divide the numerator and denominator by cos theta, it converts to tan theta and secant theta, and that is what we have in the RHS here. So we decide to divide the numerator and denominator by cos theta and not by sin theta. If you divide by sin theta, it's not that you're wrong. That is for a different identity. For this identity, you need to get secant and tan. But if you divide by sin, you're getting cot and cosecant, which is not here in the RHS. So we are not doing this, we are doing this. Am I clear, children?
Yes, ma'am.
Okay. All right. So we have to divide the numerator and denominator by cos theta and not sin theta, because only when you divide by cos theta, you're getting, it converts to the ratio secant theta and tan theta. Okay, so let's write this. You can do that in your mind actually. You don't have to work it like this and check. Just do that in your mind. Divide every term. It's enough if you check in the numerator. You don't have to check for the denominator. Just check for the numerator because you have the same thing, no, the numerator and the denominator. In both the numerator and the denominator, you have the same terms. So you just check the numerator. In your mind, you divide sine theta by cos theta is tan theta. Cos theta by cos theta is 1. And 1 by cos theta is tan theta. Yeah, and that's what we have here. But if you divide by sine, what is sine by sine? 1. What is cos by sine? Cos by sine cot. And what is 1 by sine? 1 by sine is cosecant. Now if, see children, I'm just using these terms, the numerator, sine theta, cos theta and 1, the numerator. Just do it in your mind, divide sine by sine, cos by sine and 1 by sine. Sine by sine is 1, cos by sine is cot, 1 by sine is cosecant. And that is not what we have in the RHS. So we don't divide by sine, but we divide by cos. So we have decided now the right thing. So sine theta minus cos theta plus 1. First, you should put this divided by the whole thing divided by cos theta divided by sine theta plus cos theta minus 1 divided by cos theta. See, now you'll be wondering what is this dividing both the numerator and denominator by cos theta? You know what? We've been doing that since at least 4th standard. See, now when we have 25 by 30, okay, 35. What do you do, children? How do you simplify this?
On 5 table 5 by
So what? Yeah. So what are we actually doing? You're dividing 25 by 5 and you're dividing 35 by 5. This is what you've been doing. You've divided 25 by 5 and 35 by 5. You're dividing both the numerator and denominator by 5. 25 by 35. So you're dividing the numerator by 5 and the denominator also by 5. So 25 by 5 is 5 and 35 by 5 is 7. We've been doing this. So that's what we're doing here. We're dividing both the numerator and denominator by cos theta. Now divide the terms individually. So you'll get sine theta by cos theta. Don't try, children. Please watch the screen. Minus cos theta by cos theta plus 1 by cos theta divided by sine theta by cos theta plus cos theta by cos theta minus 1 by cos theta. I had this one student from Montfort, she's now a final year student at NIT, Trichy. She has to always make sure, she'll sit in the first row and she'll be, like repeating or almost going with me. And I used to tell her, just do it softly because it's like it's echoing and I'm hearing what I'm saying. So she'll be so enthusiastic. She'll practice so much. That dedication, I don't know like if most of us have that, but she'll be so much into the class that she'll be repeating like what I'm saying now, I said this all of us can say actually. You know what I'm going to do next, sine theta by cos theta minus, you all know that. So this girl sitting behind me will repeat, she'll say along with me. So sine theta by cos theta, she'll be a little loud that I can hear it. And I get distracted when I hear somebody talking or I hear a sound when I'm talking, I forget what I want to say. So I have that problem. If somebody distracts, suddenly somebody comes and talks to me, I'll lose my chain of thoughts. And it'll be like as if I don't know how to do because I'm like, somebody distracted me, then I cannot get back to that flow again. Yeah, so this girl, she used to do that. I really liked it, but it used to be loud that it distracted me, but she was always doing that in the class. She was highly dedicated. She loses half a mark, she'll question me, why this, why that, and all that. She was so, like committed. And yeah, she did very well in her boards and all the subjects. And then you can imagine she's now an NIT, finally a student at NIT Trichy, so you know the amount of efforts I should have taken to crack NEET and all that. So yeah, so like that, you must be telling yourself now, as I'm saying this, you should also be saying that in your mind. Instead of just looking at the screen and sitting, like simply looking like this, you can just say what it is to be in your mind. That way you learn better. That's how our, primary school teachers or our kindergarten teachers taught us rhymes, no? When we learned rhymes when we were young, we hardly understood English. Correct? Because we speak our mother tongue at home. We don't talk English at home. We talk our mother tongue at home. At least in small towns like Trichy. So not that you won't be, I'm not saying that you will not be talking English at home. Like, see, everything is a language. Every language is a language. No language is more important. For that matter, Indian languages are more important because it's very old. Sanskrit is the oldest language. So, but nobody knows to talk. Most of us do not know to talk Sanskrit. Few of them are there. But we learn Japanese and Chinese. We don't learn Sanskrit. So that's one of the oldest languages on earth. And that's almost going to become extinct. Yeah, even I don't know. Okay, even I don't know. I'm only preaching. I'm not practicing that. I'm only preaching now. But somehow we've all got to understand that English is the, like the king or the queen of languages. There's nothing like that actually. Because we were ruled by the British, it's become a dominant language. It's just dominant. And, everywhere there is English, so we have to use it. But nothing can replace Indian languages, The variety we have, unity in diversity is so true in India. Every state has a language. You cannot find this anywhere in the world. Every state in India has a language, has a unique language. And in some states, there are tribal people, they have their tribal language there. So many states, so many languages, every language has a script. Few languages do not have a script, but most Indian languages have a script. And that's so beautiful. And the pronunciation, anybody who reads it will read it the same way. Unlike English, all words you cannot pronounce, like sometimes you pronounce it incorrectly. Then they say, no, it's not like that. If this comes here, it is like this. If that comes there, it's like that. But no Indian language is like that. Indian languages, if you know the sound of every letter in that alphabet, meaning the Hindi alphabet or the, Tamil alphabet, the sound, you can read it perfectly. Very few exceptions. Very, very few exceptions. But English is always crazy. You come across a new word, you will not know how to pronounce it. But Tamil and other Indian languages, any new word, you might find it difficult to read it for the first time, but you will read it correctly. That's the beauty. A lot of harm has been done to the Indians because of the British rule. We have lost so much of our scriptures. We're forgetting the importance of our temples. We visit, we go to foreign countries, we spend so much of money to learn, to visit foreign countries, but we hardly know a temple which is just next to our house. Or, temple or whatever is your religion, we fail to notice that. So we're busy, westernizing ourselves, want to be with the world. People are setting trends. So we want to be with the trend. But we should realize that, we are doing wrong by doing that. Our ancestors were, so smart. Today we have to study to be a doctor. But those days, the midwives, they delivered in the house. The veranda of the house was the delivery room. Children were born in the house and ladies did that task. So women were always powerful. They were born intellectual. Women in India were born intellectual. They did not study to be a doctor. They were born so smart that they could help in the delivery process in the house without any equipments. Just their, hands. They could handle any complication. Complications were few because women were so hardworking those days. So complications were none or few, but they were able to handle it. So see the mental strength in the women. Today also husbands are allowed to, in India, nowadays I hear husbands are allowed into the delivery room. Some of them faint. A few of them get scared and they run away. Not literally run away, but very few of them have the strength to see how the process happens. So women then were so strong mentally. It was so strong. Today we are getting scared of exams. Every school has a counseling room also because children get scared. So they have to be counseled. So we become so weak. So we need to go back to our past. Our ancestors were so strong. They've created so many good things for us, and we're just wiping out all that and running behind something which has no value. When we talk like this, we should have an open mind, and we should have reasons, or we should justify if you feel what you're doing is right. See, when I'm talking to you, it's not that I'm pointing out to any of you here. I'm not pointing out to any of you here. I'm just saying in general, I'm talking about how the world is going, or at least how our people in India are behaving, some of them. We're just following the Western culture as if that is right. Just ask yourself if it is right. So it's time, schools change, education, the way we are educated, that should change. We should be taught something about our scriptures, our whatever religion we belong to, whatever that one, so if it is Hinduism, then what it speaks, so whatever religion we follow. So we need to learn all that. We need to go back to the roots, understand, and nobody should tell you what you should do. You should be able to decide what you should do. Today, somebody sets a trend and you follow it. You don't even ask yourself if it is right or wrong. We fail to listen to our parents. Parents tell us something. Parents give us some good piece of advice, but for us, it is advice. So you should not listen. But the world is setting a trend and you're simply following that. You're not asking. You're not asking the world, or no, you're not at least asking yourself if that is right or wrong. But when people at home talk for our good, we are like, why not this? But that's what we're doing actually. Somebody's creating a trend. Somebody says you should do that, only then you're like modern. And we do that blindly. So I think we started with this one is endless actually. When we talk this, it is endless. So I have to just say enough to myself and continue with the subject. So it's something to ponder. If something is left incomplete, you should carry it forward and think, learn a lot of things, and find the right way of living for yourself. You should not take. So that's what I feel. Nobody should tell you like, do this, this is right. You can learn from others, but you should ask yourself if that is right. Yeah. All right. So coming back to this, so I was telling, nursery rhymes and all that. So that's how we were taught. We were taught, we did not understand the language at all. This teacher says you repeat with the teacher 2-3 times, and in the class, it's so nice. All the children repeating after the teacher. So and that's how we learned the rhymes, though we did not understand what it is. So that is very important. So when you repeat, when you say that in your mind, You can remember better. You understand better and you can remember better. So coming back, so sine theta by cos theta is now tan theta minus 1 plus 1 by cos of secant theta divided by tan theta plus 1 minus secant theta. So now we have got the ratios which are in the RHS. The RHS also has these ratios. Tan secant, even we have tan secant here. So somewhat, we are happy. Now next what? Next step is more important. What next is? Now here we have secant theta minus tan theta, right? So we'll also arrange it like this. This next step is arranging the terms. Secant theta plus tan theta minus 1 by secant theta plus tan theta plus 1. So the next step is about arranging the terms. How to arrange? Look at the RHS. Secant
minus secant theta.
Oh, sorry. Secant theta plus, yeah. Just a second, did I write it correctly? Sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1. Yeah, correct. Okay. Well, let me just check again then. Fine. Plus by cos sine minus 1 by. Tan minus 1 plus secant. Tan plus 1. Yeah, right. Yeah, so here it will be tan theta minus secant theta plus 1, correct? So we'll change this also then because we want the same thing here. So this also will write it as tan theta plus secant theta minus 1. Now the next very important step is this minus 1 in the numerator. Only the numerator, children, not the denominator. This minus 1 in the numerator. So like minus can remain there. This 1 in the numerator should be replaced with the relevant identity. Now we have 3 identities which give us 1. We have 3 identities that give us 1. One is sine square theta plus cos square theta. One is also cosecant square theta minus cot square theta. One is also secant square theta minus tan square theta. Now, what will you replace 1 here with?
Ma'am, secant square theta minus tan square theta.
Correct. You must replace the 1 here with secant square theta minus tan square theta because that is what is relevant to this situation. So minus only in the numerator, not in the denominator. The 1 in the numerator is replaced with secant square theta minus tan square theta. I'll just take it to the next slide, children, because I don't want to erase anything here. So I'll continue on the next slide. Tan theta plus secant theta. Tan theta plus secant theta minus 1 is secant square theta minus tan square theta divided by tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. Now, tan theta plus secant theta minus, what is secant square theta? What is secant, sorry. You can change it anywhere, children. I'll work it and I'll tell you. You're not that, now don't ask me why do you change it here. I'll tell you. You can write it as tan theta plus secant theta also. That's fine. Now, what is a square minus b square, children? What is secant square theta minus tan square theta?
A plus b into
A plus b into a minus b. We have seen that. Other interpretations of the 3 trigonometric identities. So secant square theta minus tan square theta is secant theta plus tan theta into secant theta minus tan theta. Secant theta plus tan theta into secant theta minus tan theta divided by denominator as it is, children. Denominator as it is. I shouldn't be lazy to write. 1 minute. So denominator as it is, tan theta minus secant theta plus 1. Now what next, children? Whenever there's something common, we have to take out the common factor. Now what is common? Secant theta plus tan theta is common, correct? So this whole thing is like A minus, this is like A and this is like B. So like you have A minus AB, which can be written as A into 1 minus B. Correct, children?
Yes, ma'am.
Yeah. Yeah. So secant theta plus tan theta, this is A into 1 minus B. So into 1 minus B. Secant theta minus tan theta in bracket. You know why that is important. By the denominator as it is. All right. Next, secant theta plus tan theta into 1 minus secant theta plus tan theta. Why? Because minus secant theta minus into minus is plus tan theta divided by tan theta minus secant theta plus 1. Now you can see every term is the same. Tan theta minus secant theta plus 1 plus 1. The two expressions are the same. They are just that the terms are in a different order. In the two expressions, the terms are in different order, but they are the same. You can compare this plus 1 minus secant theta plus tan theta. You cannot cancel the terms individually. The expression as a whole gets cancelled. I'm not cancelling tan theta, secant theta, not like that. The expression as a whole gets cancelled. The expression as a whole gets cancelled. And we are left with secant theta plus tan theta. We are left with secant theta plus tan theta. But that's not the RHS. So just one more step. Okay. So this one answer or this one proof, you learn many ideas. All these ideas you must remember. Secant theta plus tan theta. Secant theta plus tan theta. Now what you should do is, because this is not the RHS, what should you do? Multiply this one by multiply this one with what do you want in the denominator actually? What do you want actually in the denominator? Secant theta minus tan theta, right? See, go back there and see. You want secant theta minus tan theta. So you want secant theta minus tan theta. So you multiply and divide by secant theta minus tan theta. It's like you're multiplying and dividing by, it's like you're multiplying by 1. It is like you're multiplying by 1. Yes or no? Yes or no, children? Yeah.
Yes, ma'am.
Yeah. So see, you're multiplying and dividing by the same thing. It's like when you're multiplying and when you say multiply by 5 by 5. Multiplied by 5 by 5 means multiplied by 1. So you're not changing the value of the expression. So now multiply the numerators. So it becomes
Secant theta square minus tan theta square.
correct.
Which is equal to 1. Therefore, which is equal to 1 by secant theta minus tan theta.
Correct. Is it fine, children? See, sometimes this will be the RHS. Sometimes the RHS will be secant theta plus tan theta. Then you stop there. But here that is not the RHS. Look at the RHS. You have 1 by secant theta minus tan theta. You want secant theta minus tan theta in the denominator. So you multiply and divide by secant theta minus tan theta. So multiply the numerators and write the denominator as it is, secant theta minus tan theta. So the numerator is like a plus b into a minus b, which is a square minus b square. So secant theta the whole square is secant square theta minus tan theta the whole square, which is tan square theta, divided by secant theta minus tan theta. And this by identity is 1. Secant square theta minus tan square theta is 1 by the identity. So 1 by secant theta minus tan theta, which is the RHS, hence proved. Yes, children. Please start working this. Children, I'll just come back in 2 minutes. Can you all take screenshots of this one and continue writing? I'll just come back. Take a picture of this one, children. Done?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. Yeah, this one.
Taken, ma'am.
Okay. Yeah, all of you continue writing. One more, and we'll wind up the session for today. Please continue writing. I'll come back. Done, children? Children, I'm back.
Yes, ma'am.
Yes, ma'am.
Okay. Yes, children. First step.
I'm converting it into cos and sine.
Very good. Tell me. What is cosecant theta?
1 by sine theta.
1 by sine theta minus 1 by
Minus 1 by tan theta.
no tan.
Cos by sine theta, ma'am.
Minus cos theta by sine theta. Next step.
One minus cos theta by sine theta.
Very good. Next step.
Ma'am, sine square plus cos square minus cos theta by sine theta.
No, I don't understand that.
Ma'am, cos square theta plus sine square theta minus cos square theta by sine theta.
One minute. We cannot. I forgot to put the square here. That's what even I was confused. I forgot to put the square here, children. That's why even I was confused as to what to do next. Yeah. Sorry for that confusion. Maybe I can start again for you. Or I think you should understand. I forgot to put the square here. That's why I was a little baffled. So it's the same thing. All that you said, that whole square you'll have to just insert 1 by sine theta minus cos by sine. Sine common. I'm sorry, sine is the common denominator. 1 minus cos theta the whole square. Yeah, now next.
Sine theta is equal to 1 cos minus cos theta. Therefore, we have to
Whenever you have a by b the whole square, we'll next step write it as a square by b square. Okay. So tell me that now.
1 minus cos theta minus cos square by sine
1 minus cos theta the whole square by sine square theta. 1 minus cos theta the whole square. 1 minus cos theta the whole square by sine square theta. Next. What is sine square theta? Because you can see in the RHS we have only cos. We don't have sine. I said you should keep checking with the RHS.
Sine square theta is equal to 1 minus cos square theta.
Correct. 1 minute. I'll just register this once again. Every stage you should keep looking at the RHS. Now you're here. Actually, it's like you don't know what to do. What next? So you look at the RHS. RHS is 1 minus cos theta by 1 plus cos theta. So you realize that RHS does not have sine theta in it. So that means the next step is to replace sine square theta with cos square theta. Because the RHS does not have sine there. It has only cos. So what should be the next step? write the numerator as it is because it's only cos there in the numerator. The denominator is sine square theta. So replace that with 1 minus cos square theta. Because sine square theta plus cos square theta is 1. Is 1. So sine square theta is equal to 1 minus cos square theta. Okay, next.
Ma'am, 1.
What is 1 minus cos theta the whole square? 1 minus cos theta into 1 minus cos theta, correct?
Yes, ma'am.
1 minus cos theta the whole square. 1 minus cos theta the whole square is 1 minus cos theta into 1 minus cos theta. Then what is 1 minus cos square theta? That's like a square minus b square, right?
1 minus
is
cos theta into 1 plus cos theta, ma'am.
This is like a square minus b square because 1 is 1 square minus, you know that cos square theta is nothing but cos theta the whole square. Both are the same. Cos theta the whole square, cos theta the whole square. You don't have to write these steps, children. Don't think I'm avoiding a few steps. This is enough. Whatever I present here, this is enough. You don't have to show these steps, but you need to understand this in your mind. 1 square minus cos theta the whole square. So a square minus b square, a plus b into a minus b. 1 plus cos theta into 1 minus cos theta. 1 plus cos theta into 1 minus cos theta. So now what happens?
Ma'am, can we cancel 1 minus cos theta and 1 minus cancel?
Yeah, correct. And you're left with 1 minus cos theta by 1 plus cos theta, which is the RHS. Which is the RHS?
Yes, ma'am.
Hence proved, correct? Yeah, please write down, children. Don't take screenshots and leave the meeting. Please stay in the meeting. Write down this.
Completed, ma'am.
Okay.
Ma'am, 1 minute. Can you show the previous slide?
Yeah. Sure, sure. Done?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah.
Completed, ma'am.
All of you please
Completed.
stay. Yeah, all of you please stay in the meeting. I have to share something. Please stay in the meeting. Done writing, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Yeah. So children, I'll be sharing some videos on similar triangles. Okay, so there will be, today I'll be posting that. Today I'll be sharing similar identities from trigonometry, like we saw 4 today, is it? Okay. So quite similar to what we have done today. So maybe two identities like this, 1 or 2 like this, 1 or 2 like this, and 1 or 2 like this. Okay, so these 4. So I'll be sharing similar trigonometric identities, a few, 1 or 2 of them, that's all, with the proof, along with the proof, not only the identity, along with the proof. So you can try it yourself and then check your answer with the answer I have shared with you. So that'll be an assignment. That'll be an assignment which you should complete before Thursday. So only 4 you'll based on these 4 identities, and also I'll be sharing videos on similar triangles. So I want you to watch them. I think I'll give you time till Saturday. The coming Saturday, we'll also do a little of similar triangles. The coming Saturday, I'll give you time till Saturday, children. I'll not share many videos. I'll be very rational on that because I do understand you have your other subjects to do. It's not only math you have. So I'll be very, very rational on that. And you take time till Saturday. So Saturday's class, we'll also be doing a little of similar triangles. And see, there is nothing like getting confused, this and that. There is nothing to, if you work on it, you'll be clear. If you don't watch it and just come to the class, you will give excuses like it's confusing. She's teaching trigonometry and she's all, nothing to get confused. I've been doing this always and nobody has got confused and, or muddled with mathematics. If you listen, if you adhere to the instructions clearly, if you give time to watch the videos, then it will be clear. And in a way, I'm helping you because you're learning different chapters in school. So maybe if you're learning triangles in school, it will be useful. This will be useful. So just follow my instructions and you will be benefited. Because I always, like plan from a student's point of view. I don't stand where I am. I come to your place and think from your place. Yeah. So I just wanted to share that with you because you shouldn't think that I'm confused and I've shared, instead of sharing videos from trigonometry, she's by mistake shared from similar triangles. Not that. That's why I thought I'll just announce it before I share it. So please watch the videos before the class on Saturday. Okay. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night. Good night. Yeah, good day.
Thank you,
Good
ma'am.
day.
Thank you, ma'am. Have a good day.
Yeah. Good day, children. Thank you.
Ma'am, should we copy the